For years, running large language models like GPT or Llama has meant needing expensive, high-end hardware. Most people assume that if you wanted to experiment with massive AI models, you'd need a data center or at least a top-tier GPU. But what if you could run these behemoth models on a regular consumer GPU, even one with just 8 gigabytes of VRAM? That's where oLLM comes in, promising to make huge AI accessible to everyone, not just those with deep pockets or enterprise resources. Let's dive into how oLLM is changing the game for AI enthusiasts, researchers, and developers everywhere. Meet oLLM, a lightweight Python library built on top of Hugging Face transformers and PyTorch. Unlike other tools that simply wrap around existing models, oLLM is a purpose-built runtime designed specifically for offline workloads. This means you can run massive models like GPT OS208, GWin3 Next80B, and even Llama 3. 18B Instruct with context windows up to 100,000 tokens, all on a $200 consumer GPU. No quantization tricks, no complicated setup, just smart engineering that makes AI more accessible than ever before. One of oLLM's key innovations is its approach to memory management. Instead of cramming all the model weights and key value caches into your GPU's VRAM, oLLM streams them directly from your SSD. This clever use of disk cache means you're no longer limited by your GPU's memory, allowing you to run models that would otherwise be impossible on consumer hardware. It's a simple idea, but one that makes a huge difference in practice, especially for those working with limited resources. oLLM comes with Flash Attention 2 baked in, which is a game changer for both speed and stability. Flash Attention 2 helps reduce RAM usage and boosts the overall efficiency of the model's inference process. This means you get faster responses and more stable performance, even when working with extremely large context windows. It's another example of how oLLM leverages the latest advancements in AI engineering to deliver top-tier results on modest hardware. Handling massive models often means dealing with enormous multi-layer perceptron, MLP, layers that can overwhelm your GPU. oLLM tackles this by chunking these layers, allowing your hardware to process them in manageable pieces. This prevents crashes and ensures that even the largest models can run smoothly on consumer-grade GPUs. It's a practical solution that opens up new possibilities for AI experimentation and development. One of the biggest headaches in AI development is dealing with model conversions and compatibility issues. oLLM eliminates this problem by offering plug-and-play support for Hugging Face models. There's no need for weird conversions or complicated setup processes. Just point oLLM at your model, and you're ready to go. This ease of use makes oLLM a favorite among developers who want to focus on building, not troubleshooting. oLLM is designed to be lightweight and easy to install. It's written in pure Python, so you don't have to worry about Docker containers or complex dependencies. This means you can get up and running quickly, whether you're working on a personal project or deploying AI in a research environment. The simplicity of installation is a big part of what makes oLLM so appealing for a wide range of users. The real magic of oLLM is in its memory efficiency. For example, a 160B Qwen3 Next model that would normally require around 190 gigabytes of memory can now run on just 7.5 gigabytes of VRAM plus 180 gigabytes of SSD space. Similarly, a 13B GPT OSS model drops from 40 gigabytes to just 7.3 gigabytes VRAM and 15 gigabytes SSD. Even Llama 3B Chat can run at only 5.3 gigabytes VRAM. This level of efficiency means that even laptops can handle serious AI workloads, making advanced AI more accessible than ever. Thanks to oLLM's innovations, running advanced AI models is no longer restricted to those with workstation-level hardware. Now, even a standard laptop with a mid-range GPU can handle large language models with ease. This democratizes access to powerful AI, allowing students, hobbyists, and small startups to experiment and innovate without breaking the bank. It's a major step forward in making AI truly accessible to all. Ollama is known for its polished user experience and ease of use, especially on macOS and Windows. It's great for local LLM serving and makes model downloads straightforward. However, Ollama assumes you have at least a mid-range GPU, and relies on quantization for performance. In contrast, oLLM is all about raw inference efficiency, offering maximum context length and model fidelity without quantization. It's less about consumer apps and more about being a power tool for developers and researchers. vLLM, developed by the CMU and Microsoft research teams, has set the standard for efficient inference with its page detention mechanism. It's optimized for online serving at scale, making it perfect for APIs and distributed clusters. oLLM, on the other hand, is designed for offline use, allowing you to process huge contexts on a single GPU without the complexity of managing clusters. It's the ideal choice when you want powerful AI on a single machine. llama.cpp deserves credit for making LLMs run almost anywhere, including on phones and Raspberry Pi devices. It achieves this through heavy quantization and C++ optimization, making it great for lightweight use cases. However, if you need FP16 or BF16 precision and want long context inference with stable throughput, oLLM stands out as the better choice. It's all about balancing performance and precision without sacrificing accessibility. For the first time, you don't need enterprise-grade hardware like an A100 or H100 to experiment with 100K context LLMs. oLLM turns an affordable RTX 3060 Ti into a powerful AI workstation, opening up new opportunities for researchers, startups, and hobbyists. Whether you're on a budget or just want to test large models without massive cloud bills, oLLM makes it possible to do more with less. oLLM is a game changer for a wide range of users. Researchers can now run large models locally without expensive infrastructure. Startups can test and iterate on LLMs without worrying about cloud costs. Hackers and builders can experiment with serious models right on their own machines. It's the classic story of a small tool delivering a big punch, making advanced AI accessible to everyone. oLLM isn't just another tool, it's a proof point that clever engineering can beat raw compute power. By focusing on efficiency and accessibility, oLLM fills a critical gap in the open-source AI ecosystem. If you've ever dreamed of running GPT-level models with massive context windows on your own hardware, oLLM has made that dream a reality. As open-source AI continues to evolve, tools like oLLM will play a key role in shaping the future of accessible, powerful machine learning.